Hi guys, and welcome to this episode on DBSCAN Clearly Explained. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. As an overview, imagine we recorded the width and height of different pens. Now the objective of DBSCAN is to identify these dense clusters and classify the rest of the points as noise. How does this algorithm work? First, we count the number of points close to each point by setting the radius of a circle. This is called epsilon. Taking a look at these three data points here, we see the first point is close to 0 points, the second point is close to 3 points, and the third point is close to 4 points. Now we draw this circle around each of our points and compute how many points is it close to. We then define our core points, and these are the points close to at least x other points. In this example, let us define our core points to be close to at least 2 other points, and here they are highlighted in blue. Next, we randomly select a core point as a cluster. We extend this cluster by adding other core points that are within the set radius. Next, we add border points. These are points that are not core points but are close to other core points. In this case, we only have one border point for cluster 1. We repeat steps 3 and 4 for other core points. This results in the following clusters. Lastly, non-core points that are not close to any other core points are classified as noise. Let us now take a look at some advantages and disadvantages of DBSCAN. Some advantages include: it is easy to implement, does not require a user-defined number of clusters, this is discovered through the algorithm, it is robust to outliers or noise, it can be used for outlier detection, and can also model all cluster shapes. Some disadvantages, however, is that it is difficult to cluster data with varying densities. For example, with the following data points here, we will require different epsilon values to capture both clusters, and it is also non-deterministic, so it can produce different clusters on the same data. Finally, it does not work well in high-dimensional data. Thank you guys very much for watching, and I hope you learned something new.